Welcome to this explainer. Look, today we are diving into quite literally the most fascinating origin story in the entire universe. We're going to take a staggering 4.6 billion year timeline and transform it into a really clear step-by-step journey of exactly how our habitable world was built. As you'll see, it took a completely chaotic, domino-like sequence of violent events out in deep space to ultimately create the stable, beautiful little oasis we get to call home.
Okay, so here's our cosmic roadmap for today. We're looking at four major milestones, starting way back from a cloud of cosmic dust 4.6 billion years ago, moving right through massive planetary collisions, hellish volcanic periods, and then a literal bombardment of ice from the outer solar system. To make sense of all this deep time, we're going to follow this path. 1. Birth from cosmic dust. 2. The Great Collision. 3. The Late Heavy Bombardment. 4. Forging the atmosphere. 5. The Magnetic Shield. And finally, 6. The Rarity of Life. Let's just jump right in.
Part 1. Birth from cosmic dust.
You know, it's wild to think about, but the death of a completely different star was actually the very first trigger for our existence. Our solar system started out as a solar nebula, basically just a massive cloud of hydrogen and helium drifting out in the Milky Way. But when a nearby dying star suddenly exploded, the sheer, unimaginable force of that explosion actually forced our giant dust cloud to collapse in on itself. It started spinning incredibly fast and eventually ignited to form our sun right at the center.
Right, so from here, Earth was slowly cobbled together from the leftover debris of the sun's creation. Once the sun ignited, it was surrounded by what's called a protoplanetary disk. For millions of years, all these tiny dust particles orbiting the young sun just kept violently crashing into each other. Dust became pebbles, pebbles became rocks, and these rocks continually collided over and over until they formed actual rocky planets. And that includes our early Earth.
But hey, the Earth that emerged from this whole process wasn't exactly a paradise. Early Earth was absolutely covered in oceans of lava, burning at a hellish 12,000 degrees Celsius. It was also about 10% smaller than the Earth we know today, and it didn't even have a moon. It was just a violently hot, completely hostile rock waiting to cool down.
Which brings us to part 2, the Great Collision.
So, our undersized fiery Earth needed a pretty serious intervention to grow up and stabilize. And it got one. Enter Theia, a planet roughly the size of Mars. Theia smashed into our young Earth at an unbelievable 9 kilometers per second. To put that into perspective for you, that is roughly 7 times faster than a speeding bullet. The impact was so unimaginably violent that it completely shattered Earth's upper mantle and threw a massive amount of the planet's guts straight out into space.
This staggering collision turned Earth right back into a boiling, molten ball of lava in mere seconds. But, actually, it was a massive blessing in disguise. The collision increased Earth's overall size, and it trapped all that ejected lava and rock in a ring orbiting around us. Over time, that ring of debris merged together, giving us, honestly, the greatest gift of that violent era, the moon.
And get this. This is one of my favorite details. If you could somehow stand there and look up into the sky back then, the new moon wasn't 350,000 kilometers away like it is today. No way. It was hovering at an incredibly close 22,500 kilometers. It would have looked like this giant, terrifying molten world taking up a massive chunk of the sky, exerting just incredible gravitational pull on our still-forming planet.
All right, moving on to part 3, the Late Heavy Bombardment. As Earth finally started to cool down and form a solid crust, we run into a massive head-scratching mystery. Earth was entirely too hot to hold on to liquid water when it first formed. Any water would have just instantly vaporized. So, if we started as a 12,000-degree ball of magma, where did our vast oceans actually come from?
Well, the answer lies in an incredible sequence of events roughly 4.1 billion years ago. It was basically a literal game of planetary billiards. The giant outer planet started shifting around. Jupiter began moving inward toward the sun, but Saturn's massive gravity caught it and pulled Jupiter back. This intense cosmic tug-of-war threw off the other planets, ultimately pushing Neptune violently outward into the deep edges of the solar system.
And when Neptune was pushed outward, it smashed right into the Kuiper Belt. Because Neptune disrupted this frozen, distant belt filled with trillions of icy objects, it sent countless icy asteroids hurtling straight toward the inner solar system. For 300 million years, Earth was subjected to the Late Heavy Bombardment.
These icy projectiles absolutely hammered us, and as they melted, they delivered every single drop of water we drink, swim in, and rely on today. Seriously, next time you drink a glass of water, remember, you are drinking melted, billion-year-old space ice.
Now on to part 4, forging the atmosphere. Having water is great, but keeping it is the real trick. The early solar winds from our young sun had already stripped away Earth's first fragile gases. But around 4.4 billion years ago, we entered what's called the Hadean Eon, named after Hades, the god of the underworld. This was a period of intense, relentless volcanic activity that covered the globe in fresh lava. But crucially, these immense eruptions released massive amounts of new gases from deep within the Earth. And because Earth was bigger now, its gravity was finally strong enough to lock those gases into place.
This newly forged atmosphere accomplished some amazing things. It acted as a highly effective protective blanket. It regulated extreme temperatures, blocked deadly radiation from the sun, and most importantly, it created a closed water cycle. It basically ensured that the water delivered by those icy asteroids stayed here, evaporated into clouds, and rained back down to form our oceans, rather than just evaporating out into deep space.
Which leads us perfectly into part 5, the magnetic shield.
To really understand the fragility of our own perfectly balanced planet, we just have to look right next door. Why is Mars a dead, frozen, yet somehow boiling dirt pile today? I mean, a human without a spacesuit over there would tragically perish in seconds. What went wrong? Well, our ultimate stroke of cosmic luck is happening right beneath our feet. Earth has a continuously moving molten iron core, and that movement generates a massive magnetic field around the entire planet. This invisible shield repels the deadly solar winds, basically saving our atmosphere. Mars actually used to have a magnetic field and ancient oceans just like ours. But billions of years ago, its core cooled down, its magnetic shield died, and the sun's solar winds mercilessly stripped its atmosphere away, boiling its oceans right out into space.
And finally, part 6, the rarity of life. Once we finally started sending space probes out into the void, proving there weren't, say, dinosaurs hiding on Venus or alien civilizations building canals on Mars, a pretty heavy realization set in. We've discovered countless exoplanets across billions of galaxies, yet Earth remains the single, solitary confirmed home for life. The hyper-specific recipe of star death, planetary collisions, icy bombardments, and magnetic shields makes the environment for life absolutely the rarest thing in the cosmos.
We've seen how this planetary stage was built, piece by violent piece, over billions of years. But building the house is just the beginning of the story. As we wrap up this explainer, I want to leave you with a really provocative mystery to chew on. In a universe that is so chaotic and hostile, how did the very first spark of biology actually ignite in those new oceans? Think about that. Until we return next time to uncover the incredible origins of life itself.